Hello friends, welcome back to today's class. So in the previous class we have already discussed your input-output relations. So here is a small recap of the previous class. So these all things we tried to cover in your previous class, like what are the various input-output operations and why it is necessary, and why it is very much important, because it deals with all the three things. That's why the IO is very much important. And we discussed three important methods, which are nothing but program controlled IO, interrupt IO, and DMA. Okay, so DMA we discussed in short. Maybe in the upcoming videos we'll again go through it once again, what is DMA and all those things. So this is what we saw. The first thing is about your IO mapped, that is nothing but your standard IO, and how the standard IO operates, what are the different things in it, and what is the conflict or what is the problem with it. And we also saw that it is one of the most majorly used in today's computers. Then going ahead, we saw one example of keyboard interfacing, wherein we tried to check out how the interfacing happens. So this was the example which we saw. So the one major thing we saw here was every device has its own buffer, wherein it will be storing its data and then it will be processing through with the help of the bus and with the help of the processor. Next, we also saw these instructions in detail. And finally, we saw our memory mapped IO. What are the difference? What are the changes in memory mapped IO, and why it is very rarely used? What happens with memory mapped IO, and all those things have been seen in the previous video. Moving ahead, we also saw one more example of your program controlled IO, wherein we tried to judge how it happens and all those things. Today, we'll go ahead and start with a new topic, which is stacks. So, welcome friends. What actually is the stacks then? Why it is very much important, and all those things will be discussed in today's class. So stacks is very much essential when we try to store some data. It means that when I say when we try to store some data, it means that we are dealing with the memory. Okay. So what actually is this stacks? Stacks is nothing but it is used by a program when it tries to store any data. It helps us to organize a data in the memory. And remember friends, in stacks, all our data will be stored in the form of a data structure. Like say for example, in the form of an array or in the form of a list. In the form of an array or in the form of a list means what now? It is usually one after the other. So that's why our whole stacks is done with the help of the data structure. That is, either it will be stored in the form of an array or it will be stored in the form of a list. So we'll see in the upcoming slides how actually it is stored. Okay. And remember, there are two methods. Whenever I say it is stored in the form of an array or in the form of a list, there are two methods to do it. One is with the help of a stacks. In the upcoming slides, we'll be studying one more method, which is called as queues. So stacks and queues are the two methods which will be used to do the storing methods. That is, it is used to store the data. Okay. Now coming to so this was all regarding your first point. That is nothing but it is in the form of a list or it is in the form of a array. We are storing our data elements. So that means we are arranging our memory, and that method of arranging memory is called as stacks. Okay friends. Now going ahead, the next very important point is how does this stack reads the data. Okay. Now before I go into this, I would like to mention one more small data here. The stack is nothing but what now? It is created in the memory. I hope this point is clear. Stack is a part of a memory wherein we are storing our data elements. So this stack is not a complete memory. That means, say for example, I have 1 GB of memory, then this stack will not consist of the whole 1 GB. It is only a part of a memory. Like say for example, some 512 KB or some 1 MB, something like that. So that means what now? If I have a 1 GB of memory, stack becomes a part of that 1 GB, a very small part. It is not a very large part, it is very a small part, and it is especially in the read-write memory of the computer. It is basically available in the read-write memory of the computer. Okay friends, so make this clear. Now next very important thing, coming back to this access restriction. That means how can we access the data which is stored in the stacks? That is nothing but the memory stacks. Okay, so there is a rule whenever we go on, we want to retrieve or we want to store the data inside the stack. That means there are certain rules which are to be followed. Like the first one, you can observe here, elements can be added or removed at one end of the list only. So remember at this point, friends, what we are saying here, we can either add the elements or we can remove the elements, but from only one end of the list. That means, say for example, I have a list of elements like this. Okay, say this is 1, this is 2, this is 3, and so on. Now I want to add an element, then I can add what he's saying from only one end of the list. That means if this is my one end, this is my one end, that is one of the ends, this is my other end, that is the other end of the list. Okay, so maybe I would consider this as a entry point, and if we consider this as the exit point. But in our stacks, what happens? We don't have this. I can either add an element, say a fourth element is coming, say this is my fourth element, from one end. I am adding from the top end. Okay, then if I want to remove an element, from where I have to remove now? I have to remove from this end only. That means there is only one end to our stacks and the other end is completely blocked. This end is completely blocked. We cannot use this end. This is blocked. Right friends, I hope you are imagining the thing. To make it more clear, let us imagine there is a book rack. Right friends, let us imagine this is my book rack. Okay, and I need to keep books in it. I want to keep books in it. How do we enter into the rack? Say this is my entry point, right? So that means I'll keep my first book here, then I'll keep the second book here, then I'll keep the third book here, then I'll keep the fourth book here, and so on and so on. That means friends, if I want to remove the books, how I should remove the books then? From this end only. That means first suppose I want book number 2. I say I want book number 2. If I want to remove book number 2, then first which has to be removed? Book number 4 has to be removed. Yes, book number 4 comes out. Then which has to be removed? Book number 3 has to be removed. Then what will happen? Book number 3 comes out. Then I have to remove our book number 2. That means friends, please observe the whole series. How did we do? We first added 1, then added 2, 3 and 4. But while removing, what did we do? We removed first 4, then 3, 2 and 1. That means this method is called as last in, first out. What was the last in? 4. What is the first out which is coming outside? 4. So this is how we arrange our stack. That is last in, the fourth is last, first out. Whatever item you have put at the last will be removed at the first. So this is called as last in, first out stack. And this is the method of your stack itself. So if you understood this, that is this diagram, whatever I have drawn here, this diagram, whatever I have drawn here, and this diagram, whatever I have drawn here, then your stacks is clear. You have understood your stack. 2 points are very important. What are the 2 points? It is only one end of the list, that is only the other end is completely jammed. If I want to enter or if I want to exit, there is only one end. The next very important thing is it is last in, first out. It is last in, first out. That means if 4 has entered at the last, the 4 will be coming out first, not the 1. So these 2 concepts are very important in your stacks. Okay friends, let us move to the next point. Yeah, so in this slide we'll try to see how the stack organization has been done. I mean to say how the memory stack has been arranged. So friends, let us say this is our stack bottom. Whatever you can see here, this is my stack bottom of the stack, and from here we go on storing our data, I can say. So the data we have stored here is 0015. Okay, so we go on like that. So from 0015, 25, 08, 55 and 123. Now friends, we'll be coming across two important concepts here. One is called as SP. SP stands for stack pointer. So I'm repeating it once again. SP stands for stack pointer. So the stack pointer will be pointing at the memory location where we are currently available. So right now we are available at 0123. So therefore my stack pointer is pointing at 0123. If I move ahead from 0123 to the next location, then it will move to here 5. Okay friends, so this is first concept. The other major concept is every stack has a top of the stack. That means we call it as TOS. That means where the current stack is waiting, where we have opened the stack. So this becomes my open end of the stack. Wherever the 0, 1, 2, 3 is there, this becomes the open end of the stack. This is called as TOS. And this is the bottom of the stack. This is the top of the stack. Okay friends, I hope this is clear. So going ahead, the next very important thing, as we already discussed, it is a LIFO. That means the last in item will be going first out. So this is how the retrieval begins. Okay, now going ahead, we'll be coming across another two major things, that is a full stack and an empty stack. So a full stack is something wherein we need to be very careful. That is, if the stack is full, we have to tell to the user that the stack is full and you need to look after some other memory location. Other very important thing is if the stack is empty. If the stack is empty, then also we have to tell to the user that you have completely retrieved the items from the stack and the stack is completely empty. Okay friends. So this is very important. Next very important things are nothing but we are having two major instructions. The first instruction we have is push instruction. So what is this push instruction friends? Push instruction is nothing but, say for example, I want to add a new item into your stack. Then the instruction which we will be using is push instruction. Okay, now you can just observe the slides here. So what is happening here now? I am adding a new instruction. So when I add a new instruction, you can just observe where was my previous SP. Observe this point. One second. Yeah, where is my previous SP? Observe this point. You can see that. One second. Yeah, you can see that my previous SP is pointing at 6. So what is push friends? Push is something which will add an item into the stack. So what we want to add? We want to add this 1690. Okay. Then if I want to add an item, then from 6 my stack pointer must move to where now? To 5. That means we should subtract 1. So therefore you can observe here it is SP minus 1. Then my stack pointer has moved from 6 to 5. Then what would happen now? The new item would enter your memory location. That means from DR it has moved into the stack pointer. So from DR it has moved into the stack pointer. So I hope it is clear friends. Then what would happen now? If my stack pointer is equal to 0, then it is full. That means it would go on decrementing till here. So when it reaches here, what it means? The stack pointer is full. Therefore we have to tell your user that the memory location is full. Okay. Now if it is empty, then what would happen? A 0 would be sent. That means if it is empty, it would again go on, it will come here down and it will be giving the empty equal to 0. Okay. So I hope the push instruction is clear friends. I'll just repeat it once again. Push is something wherein we would like to denote a new item will be placed on the stack. So whenever I place a new item into the stack, what would happen? The stack pointer would be decremented. Say for example, it is pointing at 6. Then if I want to add a new item, it would be pointing at 5. And the data which is there in register DR would be pushed into your stack pointer. That is 1690. Okay. Now, next very important thing is pop. What could be pop then? Push is something wherein we are adding. Pop is something wherein we are removing. Okay. So, when I do pop, what should happen now? Whatever is there in your memory, just a small recap. Yeah. Yeah. Whatever is there in your memory should be mapped back to a register DR. If you can observe here, 1690 has been moved back into DR. Then what would happen? The stack pointer would be incremented and it would move to the next memory location 6. So it was earlier where it was at 5. Once the data has been moved to a DR, there is nothing left out here. So what should happen now? I should increment my SP by 1. So therefore what we have done, we have incremented our SP by 1 and right now it is pointing at 6. Okay, that means if my SP is equal to 11, that is after 10 there is nothing, then we say that the whole stack is empty and we should put the empty equal to 1. What did we do in the earlier case? Empty was put to 0. What we are doing right now, we are putting our empty equal to 1. Okay, then if it is at this case, what would be full? It will be 0. So I hope this is clear, friends. Just one small thing, one small recap. Just compare this statement push. What was the difference? What is it? What we have done here? SP minus 1 from DR to MSP, and if SP equal to 0, we have done full is equal to 1 and empty is kept as 0. Pop is reverse of it. What we have done here, from MSP to DR, stack pointer has been incremented and empty has been put to 1 and full has been put to 0. That's all, very simple. Next very important thing is how this memory stack has been arranged. So remember, as I was telling in the beginning of the class, if this is my whole memory, then it is divided into 3 major parts. One is program, the next one is data, and finally it is stack. Okay, friends. So just here you can compare both your push and pop. So you can observe here, push is nothing but SP minus 1 and the contents of DR are put into stack pointer. What is pop? From the memory of the stack, it is again put back to your DR and your stack pointer has been incremented by 1. Okay. So I hope this much is clear. Please watch it carefully once again, the whole video. In the next class, I will just discuss some applications of this stack pointer and we'll move with the rest of the topics. Okay. So if you have any doubts at any point, please call me or WhatsApp me, and as at the end of the lecture, every time I show you my email ID and WhatsApp number, you can message me up here. Okay. So we'll again meet in the next class, friends. Thank you for watching. Thank you.